Alrighty. Before we actually start looking at lesson 8.2, I have a little mini pre-lesson that I want to make sure that we're all set with. So we're just going to come straight along to a piece of paper over here and hop to it. So I kind of want like a brand new blank piece of paper. Okay. That's good enough. Gets the job done. So, I remember what we're doing. Okay. Follow me here. Ready? Moving the mouse. If we have 5 times 5, we should know that that makes 25, right? Also, we've got 5 squared, and you should know that 5 squared is 25. Now, if you notice, 5 times 5 and 5 squared, they both equal the same thing, and that's because they're both doing the same thing. The exponent, what that means, it's just shorthand for saying take this number, multiply it by itself that many times. So, if I had 5 to the power of 3, you could toss that into a calculator and say 5 to the power of 3 and end up with 125. But also, without using a calculator and without, just knowing that 5 cubed is 125, you could write this as, well, I know that this exponent of 3 just means I'm doing 5 times 5 times 5, right? So all that to say, if I take 5 times 5, instead of saying, well, that equals 25, I could say 5 times 5. I know that that makes 5 squared. That's what being an exponent means, right? Similarly, 5 times 5 times 5, I know that that would make, if I wanted an exponent form instead of this number solution, that would make 5 to the power of 3. So now we get to the question, and this is the part that I want to make sure we're set with, is if I take 5 to the power of 3 and I multiply that by 5 to the power of 2, what happens there? So, well, I know that 5 to the power of 2, that's just 5 times 5. And I know that 5 to the power of 3 is really just 5 times 5 times 5. And I just took these two things and I multiplied them. And now you get to see, oh, wait a minute, 5 to the power of 3, 5 to the power of 2, that's 1, 2, 3, 4, 5 multiplying times itself 5 times. So this really I could write as 5 to the power of 5. And that is the main rule that I want to be talking about today, is that if you're multiplying things that have exponents, you get to add the exponents up, right? This is just a neat little rule that you get to follow. Be very careful, because you cannot do something like this. 5 to the power of 3 plus 5 to the power of 2. These are not like terms. Multiplying them works out because when I break this down, it's all multiplying all across the board, and this becomes 5 times 5 times 5 times 5 times 5, 5 to the power of 5. With a plus sign here, this breaks down to 5 times 5 times 5, and then a plus in the middle, and 5 times 5. These guys, they can't go together, right? It's not going together like this to get that big exponent. So just another thing to note. Now, I'm bringing this up talking about 5s, but the real reason I want to talk about it is because we're going to be using a lot of variables with our quadratics that use exponents. The rules do not change between a plain old number with exponents and a variable with exponents. X to the power of 3 times x to the power of 2, it works the same way, right? It's almost easier because I don't need to worry about, well, 125 times 25. I don't know. I can't do that in my head. But I can do x to the power of 3 is x times x times x. And then I have this multiplication between the two terms. And then I have x times x because that's x squared. This becomes 1, 2, 3, 4, 5. X times itself 5 times. X to the power of 5. That's it. right? Now we have multiplication. Well, let's do a couple more of these, right? Let's do a couple examples. And I'm just pulling these off the top of my head. If I have a to the power of 3, b to the power of 2, and I multiply that times another b to the power of 2. So you might be like, this is, how am I supposed to do this? Well, I know that a to the power of 3, I can split it up into a times a times a. And I know that b squared, b to the power of 2, I can break that down into b times b. That is just what exponents are, right? That's the rule of an exponent, is this exponent symbol over here is saying b times itself 2 times, so b times b. This a, I can just bring down, and this b squared will also split into a b times b. And now, you just count them up. A times a times a times a, that's 4 a's multiplying times themselves, so it's going to be a to the power of 4. B times b and b times b, oh look at that, I ended up with a to the power of 4, b to the power of 4. That would be the answer to that multiplication. I'm going to give you 2 to do. We'll do the work, and then we're going to look at division. Let's try x to the power of 4, y cubed times y squared x to the power of 7. Why not? So, I'm looking at these. Y to the power of 3 would break up into y times y times y. This would break up into y times y, which I know is going to give me 3 y's over here, 2 y's over there. That's going to give me y to the power of 5. I'm definitely not going to break these up, but I can see this is going to give me x times itself 4 times. This is going to give me x times itself 7 times, which means I have 4 and 7 x's all together. That's going to be x to the power of 11. That's it, guys. That's all this is, right? Just making sure we're good with this. I'm going to give one more. Let's do j to the power of 8 and I to the power of 7 times k to the power of 3 times j to the power of 4. So I've got these j's, right? 8 j's and 4 j's. That's going to make j times itself 12 times altogether when I multiply all this. So it's going to be j to the power of 12. This I to the power of 7, there's no other i's to add up to it. So it just comes along for the ride. I to the power of 7. This k to the power of 3, it has no other k's that are multiplying to make more. So it's just going to be k to the power of 3. That is your solution over there. So just getting some practice with multiplying some exponents of similar variables. Let's do some division. Division's the same thing, just backwards. And we'll see what that means in a second. So let's do this with some 2's first. If I have 2 to the power of 3, you might know off the top of your head that that's 8. Now you might need to say, well, 2 to the power of 3, let's break it down. 2 times 2 times 2, right? This just says 2 times itself 3 times. 2 times 2 is going to get me 4. 4 times 2 is going to get me 8. That is why 2 to the power of 3 gets 8. Awesome. If I say 2 squared, you should know that that's 4. But again, you can break this down to 2 times 2, which is 4. Yeah, that checks out. If I want to do something like 2 cubed divided by 2 squared, since these are numbers, yes, it works out that I could say, well, I know that 2 cubed is really 8, and I know that 2 squared is really 4, and then I know that 8 divided by 4 is 2. You can do that, right? You can do that. But again, just like in the other side over here, we start with numbers, we want to get to variables. So let's explore how this could work. Well, this 2 to the power of 3, instead of switching it to an 8, I could really switch it over to 2 times 2 times 2, because that's what 2 to the power of 3 is. Similarly on the bottom, I could say 2 squared is really just 2 times 2. And now you start to see what's happening here. I have set it up in a way such that I have the same thing on top and the same thing on bottom of a division sign. So these 2's can cancel, right? 2 divided by 2 cancels out to a 1. 2 divided by 2 cancels out to 1 over here also. And we're left with just 2, right? Let's do one more example with 2's. So you break these, you open these up, but really what you're seeing is this is 2 to the power of 3, so it's going to be 3 2's on top, 2 to the power of 2, 2 2's on the bottom. That means you know that you have 3 on the top, 2 on the bottom. You can take away 2 of the 2's, and you're left with a single 2. 3 take away 2 gets me an exponent of 1, which we leave invisible. So this is what we're going to practice again more. Let's check out what 2 to the power of 4 is. That's 2 times 2 times 2 times 2. That's going to be 4 times 2 times 2. That's going to be 8 times 2. That's going to be 16. So now I've got 2 to the power of 4, and we're going to try out divided by 2 squared. This is me, by the way, just coming up with examples. Here was one example of dividing with exponents. Here's our second example of it. I'm telling you right now, once you get to it, you're going to be able to see right away 2 to the power of 4 divided by 2 to the power of 2. That is just 2 squared. Because I have an exponent of 4 up here, an exponent of 2 on the bottom here. So I'm going to take 4, take away 2. Exponent of 2 is what's left over. Let's break it down to see how that works, though. 2 to the power of 4 is going to be 2 times itself 4 times. 2 to the power of 2 is going to be 2 times itself twice. Boom, boom. It cancels out. I'm left with 2 times 2, which is really 2 squared, which works. Just to see how this works with real numbers, 2 to the power of 4 is 16. 2 to the power of 2 is 4. 16 divided by 4 gets me 4. 2 squared, guess what that is? Is 4. It works out. Let's follow that same rule to do like 3 examples with variables, and we're done. Let's say I have m to the power of 7. And I want to divide out m to the power of 2. Now you can break this down, and we'll do it for this example. You can break this down to, well, I know that's really just, I smacked the table. M times m times m times m, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. All divided by m times m. So now I'm going to say, well, that'll cancel with that. That'll cancel with that. And I'm left with 1, 2, 3, 4, 5 m's multiplying by themselves. So that's going to be m to the power of 5. That's it. Now, if you you can always try to break it down and then just cancel out. Or you can say, hey, if I just subtract the exponents when I'm dividing here, m to the power of 7 divided by m to the power of 2, 7 take away 2, m to the power of 5. That's the simple rule you can follow. Let's do let's do one more of these and then one last thing. It just occurred to me. So let's try and do it with 2 different variables this time. I'm going to say a squared and b to the 5th power. Now I'm going to get I'm going to divide out an a, and I'm going to divide out a b squared. If I break this down, this is going to become a times a and b times b times b times b times b. 1, 2, 3, 4, 5 b's. All over a single a, because that's all that's there, and b times b. This a will cancel with that a. This b with that b with that b. See what's left. An a, 1, 2, 3, b to the power of 3. That would be our solution. Or you could say a to the power of 2, divide out an a to the power of 1, 2 minus 1, a to the power of 1 left over. B to the power of 5, divide out a b squared, 5 take away 2, b to the power of 3. So you can even do it with multiple letters, it's fine. The last thing we'll do is I can do this with like full terms, with full variable terms. If I have 2x squared, and we're going back to multiplication for a second, I want to multiply times 3xy, we just multiply this stuff together. 2 times 3 makes 6. X squared times x brings us to x to the power of 3. The y, just coming along for the ride. If I wanted to do something like maybe 6x cubed y, and I want to divide out 3xy, well, you just divide each part of it separately. The coefficients divide. 6 divided by 3 is going to make 2. X cubed, divide an x away. You're now left with x squared. Y, divide a y away. Well, they cancel. And you got that. Let's do one more example. 2 more examples, maybe. How long is the video going? It doesn't say. I don't know. 2 more examples. Let's do more division. Because I think the multiplication... all right, we'll do one more multiplication example, one more division example. Let's do 14ab times 2a squared b cubed. Okay, well, I'm just going to do each part. 14 times 2 is going to be 28. A times a squared, that's going to be a, that's going to be a to the power of 3. B times b to the power of 3, I have a single b over here, and 3 b's multiplying times themselves over there. I'm left with b to the power of 4. Let's do a division, final division over here. Let's do 42 x cubed y to the 4th, and we'll divide out a 6xy. Do the numbers. 42 divided by 6 is going to get me 7. 42 divided by 6 is 7. X to the power of 3, divide an x out, is going to get me x to the power of 2, because this is x times x times x. So one of those 3 x's would cancel with the x on the bottom, left with 2 x's on the top, x times x. Y to the power of 4, divide a y away, that leaves me with y to the power of 3. So hopefully you get that. I think at the end of the Edpuzzle video of this, for my Google Classroom kids, I'll put a couple extra questions coming up right now for you to just get more practice doing these things. If you need help, send me an email. And this is super, super vitally important for understanding the next lesson that we're going to be looking at next week, because this video was long enough. Cool. Make sure you get it, though, because the next lesson really, really relies on you understanding what we talked about today. Coolio, let's pause it. See ya.